script? Where's my script? I think I have a lot of time. 10,000 fish are waiting for me.
Okay, I'll answer any question you should answer.
This?
Do it, alright? The camera is there. And no smoking, no cursing, alright?
Good morning, everyone. My name is Yu Hao Xiang. I'm a biologist. I got question 1. What is Clarias batrachus? Cannot Google AI . So this Clarias batrachus is a native catfish here in Southeast Asia. Southeast Asia, you know, right? Good. So like other chordates, it has a post-anal tail, pharyngeal slits, hollow nerve cord, and a notochord. This four you know, right? This four you know, right? Cannot say you don't know. No, right? Do you know it?
I don't know.
So it has special breathing organs that allow it to breathe on land for at most 18 hours. So paired with its fins, it can walk on land by carrying it itself across the land from a water source to another water source. So, do you have the photo? You know the photo?
What photo?
Your email.
No.
You got the photo or not? So you see the diagram here? So it has a dorsal fin, a caudal fin, an anal fin, 2 pelvic fins and 2 pectoral fins. So it has a pair of eyes and 4 pairs of bubbles. It also has a mouth. So for its habitat, essentially it loves to live in stagnant waters. So Clarias batrachus loves to live in rivers, swamps, streams, ponds, and sometimes flooded rice paddies, and mostly areas that are temporarily pools of water that also may dry up. What is its classification? Clarias batrachus is from the kingdom Animalia, phylum Chordata, class Actinopterygii, order Pseudoforms, family Claridae, genus Clarias, and species Batrachus. So its name is Clarias batrachus.
Okay, so let me explain about what the successful of catfish due to their morphological and also physiological adaptation.
Firstly, the catfish so successful is about their morphological and also physiological adaptations. Firstly, in the hypoxic water, catfish have a sac-like suprabranchial organ which will help them to store oxygen. After that, it also thought it will reduce lift, which would reduce the surface area to prevent the diffusion of oxygen back into the water. After that, they also have the highly vascularized absorbents, which is dendritiform organs with the mucus to maximize the surface area for gaseous exchange. After that, this specialized organ also could reduce the permeability of the gases to diffuse out into the water again. For the physiological adaptations, they have the facultative air breathing, which catfish drop the air out from the water, and then it could be used inside the water. After that, catfish also have high acid tolerance, which could let it live inside the hypoxic water. Secondly, for overland travel, catfish have the elongated body to reduce the friction when it moves on land. After that, they also have the cartilaginous dendritiform organ, which will let it breathe on land without collapse. And for the physiological adaptation, it exhibits amphibious osmoregulation to keep their skin moisture. After that, they also could breathe by highly vascularized skin on the land. In addition, they also would secrete mucus, which would act as the lubricant when it moves on land. Thirdly, is the finding food of catfish. They have the long and sensitive barbels, which could detect the environment. And they also have the Weber apparatus, which could connect the swim bladders with the inner ear. And this is to amplify sound so it could detect the environment surrounding. After that, they also have numerous taste buds on their skin, and this also let it have a name of swimming tap. In addition, they also have the olfactory system, which have the nostrils with lamella packed with the receptors to detect the chemicals surrounding. For the physiological adaptation, they have the enhanced chemoreception, which could detect the low concentration chemicals in a longer distance. They also exhibit alternative feeding, which let it feeds with the food which is readily available in the environment. For the drug survival technique, they would burrow using their body to keep them avoid from the water loss due to high temperature and also sunlight. After that, for physiological adaptation, they exhibit activation to keep dormancy in a hot and dry period. After that, for their self-defense, for self-defense, they have serrated lockable stiff pectoral spines to let it harder to be swallowed by predators. After that, for physiological adaptation, they have mucus to let it harder to be captured by predators, and also have and for their mucus also have an antimicrobial action, which help it to resist towards infection and also pollutants.
Excuse me, what is the difference between the suprabranchial organ and the dendritic forms?
Okay, for the difference of suprabranchial organs and also dendritiform organ is they have different structure, different location inside the package, and also they have the different function. For the structure, suprabranchial organ is the hollow respiratory chamber above the gill. Whereas for the dendritiform, there is a tree-like and tightly vascularized respiratory tissue. And for the location of suprabranchial organ, it is located in a hollow cavity, the suprabranchial chamber, and in the upper part of the gill cavity. And it's just behind above the normal gills. After that, for the dendritiform, they're located in the suprabranchial cavity also, but it was located behind the gills, which connected to the gill arches. After that, for their function, suprabranchial organ mainly would host the gases and provide the air for air-moving organs. After that, for dendritiform, then it would increase the surface area for the gaseous exchange. And that's all for the differences between the suprabranchial organ and also the dendritiform organ.
I will talk about human interaction with Clarias batrachus. Clarias batrachus, which as we know as modern catfish, has the unique ability to move across land for short period in search of better environmental conditions. While this helps species to survive, it also can create ecological conflict. When released irresponsibly, it may enter aquaculture farm and prey on farm fishes, which leading to economic loss for farmers. At the same time, Clarias batrachus can act as an environmental indicator. The abundance and health of this species in a pond or water body reflect water quality and pollution levels. Changes in population can therefore be used to assess overall health and sustainability in the aquatic ecosystem. In many Southeast Asian countries, including Malaysia, Indonesia, and Philippines, Clarias batrachus is an important food dish. It is widely consumed as local delicacy, providing a nutritious source of protein and supporting local livelihood through small-scale fishing and market sales. In native habitats, this species play an important ecological role. As both predator and prey, it controls invertebrates population, recycle nutrients, and support energy flow within the food web. By stirring water sediments, it releases nutrients with microhabitats and help maintain overall ecosystem balance. In invasive habitats, its impacts become highly destructive. It competes aggressively with native fish, especially in low oxygen waters where many native species cannot survive. They also prey on eggs and juveniles of fish and amphibians, reducing breeding success and leading to population declines. In addition, its constant movement increases water turbidity, triggers algal blooms, lower oxygen levels, and may introduce new parasites or diseases. While in human-dominated ecosystem, its effect is mixed but often problematic. In aquatic system or aquaculture system, it preys on farm fish and competes for feed, resulting in economic losses for farmers. In rice fields, it can help control insect pests, but excessive burrowing might disrupt or disturb the crops, damage irrigation system, and threaten small culture species.
In
in a case study done by Saroj Kumari, he highlights the general morphology and physiology of Clarias batrachus and its ability to move on land where it can become invasive when disposed of improperly outside of its native habitat and disrupt native ecology. Besides that, in a case study done by Bhupesh Giridharan et al., an antimicrobial protein from the mucus at the epidermis of Clarias batrachus is purified and characterized. The antimicrobial protein showed significant antimicrobial activity against broad-spectrum bacterial and fungal organisms, including multi-drug resistant clinical isolates. This protein could potentially be used as a treatment for several bacterial and fungal infections in humans.